So transformations of exponential functions. So our learning goals are to learn to draw the parent exponential, which is y equals some base number, so b is a number, to the exponent x, by making a table of values. So you always have to make a table of values to get your parent function. Okay? We're learning to draw and label the horizontal asymptote of an exponential function. So an exponential function always has a horizontal asymptote. We'll see why. And we're learning to sketch the image function. So y equals a, let me get my highlighters out. So these would be the vertical transformation. There's my vertical structure compression. And there's my vertical shift up or down. And here's my horizontal structure compression and my horizontal shift left or right. Okay? And then there could also be reflections as well. Okay? So we're going to do that by making a list of all of our transformations and creating a parent function. Okay? And then following our list. Okay, so complete the following table. So here's our exponential function, y equals 2 to the x. We're just going to draw some parent functions now to get used to what the parent functions look like. Okay? So if y equals 2 to the x is our parent, what would the y value be if x is -3? No. Okay, so it would be 2 to the -3. So I'm replacing x with -3. And what's 2 to the -3? 1 over 2 to the +3, which is 1/8. Okay, so -3 and 1/8 is an ordered pair on our graph. So -3 and 1/8, so like half is here, 1/8 is like really close to the x-axis. Okay, really close to it. What about when x is -2? I have y equals 2 to the -2, which is 1 over 2 to the +2. Agreed? Which would be 1/4. So here's 1/4. Not halfway yet. 2 to the -1 is 1/2. Okay, 2 to the -1 is 1/2. What about 2 to the power of 0? Anything to the power of 0 is 1, not 0. Good. So 0 and 1. And then these ones we could probably do without writing them down, but 2 to the power of 1 is 2. So 1 and 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. So 3 and 8. You can see, like if I put 4 here, 2 to the power of 4 is 16, it's going to go way up high. What's going to happen as I get like to say -10? It'd be 1 over 1024, right? 1 over 2 to the 10th. That's going to be, is that going to be above or below the x-axis? 1 over 1024. Above, right? Am I ever going to touch the x-axis? Am I ever going to go below it? No. So that means there's an asymptote here. Remember, an asymptote is a line that a curve can get infinitely close to, but never touch or cross. Okay, a line that a curve can get infinitely close to, but never touch or cross. So our horizontal asymptote for a parent function is always going to be y equals 0, the x-axis. Okay? And then you want to draw this in with a smooth curve, arrows on the ends, best you can. You're not going to be perfect because we're plotting like these decimal numbers and we're just kind of doing our best. But you hear about exponential growth curves all the time, especially with coronavirus, okay? So it starts off slowly, but then once it picks up pace, it takes off, okay? That's what exponential growth is. So this shows exponential growth here. What would the domain be of this function? Yep, all real numbers, yeah. For every x, there's a corresponding y value. What about the range for this, lowest to highest? All real numbers created as long as? Yep, because we don't have any negatives down here. So as long as y's are strictly greater than 0, not greater than or equal to, because we never touch the y-axis. Okay? All right, so a similar one, y equals 3 to the x. So it's got a different parent function because the base is now 3. So this number, I usually tell kids put it in a box so you know that it's the base, especially when there's lots of stretches, compressions, shifts, all that stuff. Remember that that's the base and it's not a transformation. That's the biggest mistake people make, okay? That's the base, so that helps you get the parent, okay? So that means we have to figure out what y equals 3 to the negative 3 is to complete our table of values there. So we have to know that means the same as 1 over 3 cubed, which is a 27. Okay, already really close to the x-axis on our scale, okay? One over 3 squared, so a 9. Oh, we're not playing one, we should do that. 1/3. Finally, one that seems plottable. Okay, so negative 3, go way down here. And 127, like it's pretty much, like I can't even get that close to the x-axis. Yep, yep. A 9, same thing, like it's so close. A 3rd, finally one that I can wrap my head around a bit there, but that was more like a half. We're just going to do our best, right? All right, and then 3 to the 0. Any number to the exponent 0 is 1. 3 to the 2, sorry, 3 to the 1 is 3. So 1 and 3. 3 to the 2 is 9. So 2 and 9. And 3 to the 3rd is 27. And it's way up here. Right at the top there. Room for it. Basically, you can see just changing the base by 1 makes the growth curve a lot steeper. Okay. We're going to have a horizontal asymptote along y equals 0. And then just draw it in as best you can. Arrows on both ends. That didn't look very good there. Should be smooth. And then we need domain and range. It should be the same. So the domain is just all real numbers. And the range is again all real numbers as long as y is strictly greater than 0. Okay? So That's another parent. Okay, y equals a half to the x. Different parent. So think about doing 1/2 to the -3. What would you do with that? Yes. So flip this half to 2/1, which is just 2, and then change your exponent to positive. And 2 to the third is 8. So -3 and 8 is a point. And same thing with y equals a half to the -2. That would be the same as 2 to the +2, which is 4. So -2 and 4. And then half to the -1 is the same as 2 to the +1. So -1 and 2. Half to the 0, any number to the exponent 0 is equal to 1. So that 0, 1 is always going to be a part of your parent function, which is good to know. Okay, your parent. And then a half to the power of 1 is just a half, so 1 and 1/2. A half to the power of 2 is a quarter, so 2 1/4. And then a half to the third is an 8, so 3 and an 8. And then we're going to have a horizontal asymptote along the x-axis. And then join with a smooth curve. So this was not called an exponential growth curve. Anyone know what it's called?
Exponential decay.
Yeah, exponential decay. So we start off high, and then we get lower and lower and lower as we move from left to right. So this one shows exponential decay. Our domain and range are still the same though. We still have all real numbers for our domain. And our range is all real numbers as long as they're strictly greater than 0. Okay, so exponential functions have the general form y equals a b, which is the base. Okay, so that's what goes in the box. That tells you the parent. And it always has to be a positive rational number. Okay, the base. So again, you're highlighting, this is vertical, vertical, horizontal, horizontal. So our steps: identify the base and make a table of values to sketch the graph of the parent function, label the asymptote, list the appropriate transformations. Okay, so if there are two things happening in the exponent with the x, you have to put it in factored form in the exponent, okay? So you get the correct horizontal shift. Move your horizontal asymptote with the vertical shift, if there is one. Okay, label the asymptote with the equation that should say y equals the number. Apply the transformations to each point of your parent. Okay, and then label your image function. Right? Okay. Let's try one. So sketch the graph of the exponential function y equals 3 to the x plus 2 minus 4. State the transformations that have occurred to the base functions in words. State the domain and range. Okay. First step was to figure out what the base for the parent function is. So what's going to be our parent function? We have y equals 3 to the x. Okay? That's what you make your table of values for. And you usually always use -3 to +3 for your x values. You may not fit them all on your graph, that's fine, but you should use those and see if they fit. Okay? They may or may not. And they may be helpful if you have a vertical compression that allows you to find out where your next point would be. And she'll come across one of those. All right, so 3 to the -3. So you might want to do that on scrap paper or your whiteboard, but 3 to the -3 is 1/3 cubed, which is 127. Okay? So you have to think through that each time, either in your head or on a scrap piece of paper, fit it on your paper somewhere. 3 to the -2 is a 9. Try to fit these so they 3 to the -1 is a 3rd. 3 to the 0 is 1. 3 to the 1 is 3. 3 to the power of 2 is 9. And 3 to the power of 3 is 27. So now we'll fit whichever one we can on the graph, and this is what we'll use our color for as our parent. Okay, we'll use pencil for our image in case you make mistakes while we're trying to get there. All right, so -3 and 1/27 is really close to the x-axis. So is -2 and a 9. -1 and 1/3. 0 and 1. 1 and 3. 2 and 9, and that's all we can fit. We can't fit the 3 and 27 points on, but we're using arrows anyways. And we have to draw our asymptote in. I'm going to use the same color so my graph doesn't look too confusing in the end. So this is y at 0. Arrows on both ends. There's my parent. Okay? Now I'm going to list out my transformations. Well, I made a list out my transformations. I'm going to check and see if I'm ready to do the highlights. Is it ready to be highlighted or not ready? Ready? Everybody good? There's only one thing happening in the exponent with the x. Okay, so that's going to be green. The +2 there, and then this is going to be yellow, the -4. Okay? So what are those transformations in words? Sebastian.
Horizontal shift.
Yes, horizontal shift. Left 2. And -4. And
Vertical shift down.
yes, vertical shift down 4. Perfect. Okay, so once you've got your transformations listed out, you look and see if there's a vertical shift. If there is, we're going to move our asymptote to that new location. So we're going to move our horizontal asymptote down 4. So I'm going to use my pencil now. 1, 2, 3, 4. So there's my new vertical asymptote. And it's y equals -4. Okay, so it has the equation y equals -4, and it's like a barrier, so my point should line up. It tells me whether I'm going in the right direction or not when I'm doing my graph. Okay? So I like to start with this point, always the one that's 1. And I'm going to shift it left 2 and down 4. So left 2 and down 1, 2, 3, 4 puts it right there. Okay. That's my 0, 1 point. Become there. Then I'm going to shift this point. So I'm going to shift it left 2 and down 1, 2, 3, 4. I always do my whole number ones first because they're easier, and then I do my crazy decimal ones after. So left 2, down 1, 2, 3, 4. Now this one is a 1/3 there, so I'm going to move it left 2. So it's a 1/3 of the way above that asymptote. And then you should be able to see what's happening here. You're just going to get closer and closer to the asymptote. So those last two, I don't even move. I don't even bother. Okay, I just know they're going to get closer and closer to the asymptote until they're practically on it. Okay? And then I join my points with a smooth curve as best that I can. Arrows on the ends of each. And then we can label it, or you can do like a legend. So I'm underlining that one in pencil and underlining this one in my pencil crayon, my parent. So there's my 2 different graphs on the same curve, and I use like a legend rather than labeling them right on the graph. You could label them right on the graph if you want to. And then we have to state the domain and range of the image. So of the new one, if you want to call it that, not the parent. So what's the domain of the parent? All real numbers, good. And what about the range of the parent? Yep.
All real numbers as long as y is greater than -4.
Yes, strictly greater than -4, because our asymptote moved, so they have to be above -4. Okay. So there's an example where there was just shifts. That one's not too bad. Okay. Any questions so far? Good so far? All right. Next one, sketch the graph of the exponential function, state the domain and range. So our first step is to figure out what the parent function is. So what's our parent? Anyone? Jackson? Y equals 4 to the x. How did you know that? So if you're not sure and you're worried, you always find your exponent and look at what's right before it. Okay, so there's my exponent. What's right before it is 4, so my parent must be y equals 4 to the x. Okay, so now I have to make a table. I'm going to give you time to make the table, because we have to. Okay, so who had 1/64 or -3? Anyone A bit more explanation on how to get that. So we're getting the hang of that. So that's going to be crazy close. 1/16 for -2. Crazy close, but I don't know if you can make it look a little bit higher. 1/4. 1/4. 16, not 8, careful. And that's all we're going to be able to fit on, but this one would be 64. And then my horizontal asymptote, don't forget that y = 0. And then sketch it in best you can. Underline with your legend. Everybody good there for your parents? Okay, so now you look at the image and decide whether it's ready for highlighting or not ready for highlighting. Ready? So you look at the exponent, there's only one thing happening in the exponent. So I'm ready for highlighting. So I'm going to have my negative sign highlighted in yellow, my half highlighted in yellow, and my +5 highlighted in yellow. So those are all vertical. My only horizontal is the -3. But there should be 1, 2, 3, 4 transformations written there. And I like to list them from left to right because that's how I apply them when I'm doing it. Okay, so the negative sign would be the first one that I write down. And what do we call that transformation? Yes, a vertical reflection. And the 1/2. Section? Good, so it's a vertical compression, and then you have to say by a factor of 1/2. And the next one is the -3 in the exponent. What's that going to be? Does?
Horizontal shift, right 3.
Yes, a horizontal shift to the right 3. And then the +5. Yep.
Vertical shift up 5.
Good. Vertical shift up 5. And then once you're done your transformations, you see if there's a vertical shift, and you do that to your asymptote. So we're going to put our new asymptote up 5, which is a good judge for whether our points are moving properly, if they make sense, or if we've made a mistake on one of them. So that new asymptote is going to be at y = 5. Okay. So if I start with this point, the 0, 1 point, and I start applying my transformation. So first of all, I'm vertically reflecting it, so it goes down to -1. Is everybody good there? Now I'm compressing it by a factor of 1/2, so instead of being 1 below, it's only going to be 1/2 below. And then I'm going to move to the right 3, and that 5. So it should be right there in that halfway spot underneath. Okay? Asymptote. All right, so then the next one I'm going to move is this one. So the first thing I'm applying is a vertical reflection. So right now that point is 4 above the asymptote for the x-axis, so now it's going to be 4 below it. And then I'm compressing it by a factor of 1/2, so instead of being 4 below, I'm only going to be 2 below. 1/2 is apart. And then I'm going to the right 3, and that 5. 1, 2, 3, 4, 5. So there's my second point there. Should be 2 below. Okay, the next one I'm going to do is this one. So first I'm going negative 16 below, but I can't fit it on, but I'm going to keep that in mind. Does everyone see that I know I'm negative 16 below, okay? So I have like a holding spot off my chart, but then I'm halving that. So negative 16 below, half of that is negative 8 below, which puts me here. Yes? At negative 8. And then I'm going to go 3 to the right, which is right at the edge of my page, and not 5. 1, 2, 3, 4. No, I'm sorry. 3 to the right puts me here. So I was down at negative 16, now I'm up to negative 8. Over 3 and up 1, 2, 3, 4, 5, right there. Room right there. Okay, so those are the easier points to do. The next ones aren't bad, it's hard to think through it in your head. So that's positive a third. Okay? So the reflection is, now I'm at negative a third, which is here. But now I'm halving that distance, so I'm even closer to the asymptote. Do you agree with that? So I'm even closer to the asymptote, and then I'm going right 3, 1, 2, 3, and not 5, so I'm almost like at the asymptote. So at that point, I just put the other ones in, like they're just closer and closer, and then I just draw my curve in smoothly. Okay, so these ones are just underneath there. And so then you're going to draw in your curve, arrows on both ends. Like that. And then I'm going to underline this one in red as my legend. And then I need to do the domain and range of it. Domain. All real numbers. That doesn't change. The range does, though. So the range for this one is going to be all real numbers as long as greater than? Less than 5, yes. Because we have that vertical reflection. Okay? Alright. Good. Right? Excellent. Didn't get our parent drawn anyways before break. So sketch the exponential function y equals 2. And then in brackets a third to the exponent negative a half x minus 3. State the transformations that have occurred to the base function. And state the domain and range. Okay. So who can tell me what the parent function is? Yes, good. So you have to write it with brackets, so y equals 1/2 in brackets to the power of x. And then I'll pause it. Sorry, it should be a third. Should be a third. Good. All right, so our parent is right before the exponent. Pause it again. All right, so let's see if our tables are right.
Let's go.
Oops, I didn't spread that out very well. 0. Okay, so how many people got positive 27 for a third to the negative 3? Oh, good. How many people got positive 9? How many people got 3 for negative 1? Yes, good. And 1 for 0, not 0. And then 1/3 for 1. Yes? 1/9 for 2 and 1/27 for 3. All right, so now we've got to plug those on. So negative 3 and 27 doesn't fit on my graph. Negative 2 and 9 does. Negative 1 and 3 does. 0 and 1 does. 1 and 1/3 makes sense of, and then they just get lower and lower. Okay? Then I'm going to draw in my asymptote and label it y equals 0. And then try my best with a smooth curve here. So that should be your parent function for this. So then we ask ourselves if we're ready to highlight yet or not. Yes? Okay, so this is just a negative 1/2 in front of x, even though that's 2 transformations. I don't need to put it in factored form because they're both multiplying. So we've got the 2 out front is vertical, and the negative 3 at the end is vertical. The negative sign is horizontal, and the half is horizontal. Okay? All right, so now we want to write out what they are. So what is the first 2 we come to? It's yellow, so it's vertical. Vertical is what it looks like, so it should be a vertical stretch by a factor of 2. And then the negative sign, the green negative sign?
Horizontal.
Horizontal reflection. And the 1/2 that's green?
Horizontal stretch by a factor of 2.
Good, horizontal stretch by a factor of 2. And the negative 3 is a vertical shift down 3. So that's where our asymptote is going to move. So down to negative 3. All right, so we're going to do our transformations the best we can here. So start off with 0, 1, we move first. So vertical stretch by a factor of 2, so I'm going to double my distance away from the x-axis, so I'm up at 2. Horizontal reflection, left or right from the y-axis, I just stay on the y-axis for this one. Horizontal stretch, just stay on the y-axis, and then move down 3. 1, 2, 3. So I should end up here for that point. So 2 above the horizontal asymptote, the new one. Okay? All right, now let's look at this one here. So the first thing I'm going to do, if I follow, is vertical stretch by a factor of 2. So instead of being 3 above the asymptote, I'm going to be 6 above. And then a horizontal reflection, so instead of being 1 to the left, I'm going to be 1 to the right of the y-axis. Horizontal stretch by a factor of 2, so instead of being 1 to the right, I'm going to be 2 to the right. And then down 3. 1, 2, 3. So that's where our second point is. You want me to go through that again? No? You guys catch that? Okay. Right, so this is the next one I'm going to do. So I'm at 9. If I double it, I'm up at 18. Okay? Which I do have up here. So I'm doubling it. So I'm up here at, in red, up here at 18. And then horizontal reflection. So instead of being 2 to the left, I'm 2 to the right. Then I'm doubling that distance to 4 away from the y-axis. That's my horizontal stretch. And then a vertical shift down, 1, 2, 3. So there's my first 3 points moved. Now I'll look at my third here. So I'm starting off with a vertical stretch. So instead of 1/3, I'm going to be at 2/3. Horizontal reflection, so instead of 1 to the right, I'm over here at 1 to the left. And I'm doubling that, so 2 to the left, and down 1, 2, 3, so 2/3 of the way above in that square. Doesn't look great here. Just take that little top piece off on my dot. That's about 2/3 of the way. Okay? And you know how my pattern, because of the horizontal stretch, is every 2 squares? I'm doing something, so over 2, down something, over 2, down something, over 2. So I'm not going to even do the other 2, but I'm going to go over 2 and then down, and then over 2 and then down even more. Okay? I don't even worry about those last ones because I know they just get closer and closer to the asymptote. Okay? So then once you've got them drawn in, you're going to join them with a smooth curve. Best that you can. Arrows on both ends. And then you need to do the domain and the range. So our domain is all real numbers, as usual. And our range is all real numbers as long as they are strictly greater than -3. And remember, still checking that your words agree with your picture is always a good thing. Is it stretched out? So is it steeper than the blue one? Yes. Okay, it takes up more space vertically. Is it reflected horizontally? So they're mirror images this way? Yes. Horizontal stretch by a factor of 2? Yes. Takes more space up horizontally per little segment, I guess. And down 3. Okay. Sketch the exponential function y equals 1/2 to the power of 1/3 x minus 2 minus 1. State the transformations in words, state the domain and range. So what is the parent for this one? Y equals 1/2 to the power of x. Good. So I'll let you guys make a table. So 1/2 to the -3 is 8. Yes? 1/2 to the -2 is 4. 1/2 to the -1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. 1/2 to the 2 is 1/4. And 1/2 to the 3 is an 8. Okay, so let's plot those on. So -3 and 8. -2 and 4. -1 and 2. 0 and 1. 1.5. 2 1/4. 3 and an 8. I noticed that I've got a lot of room up here. So if I want to put another point in, what can I do to figure out where that other point would be? Yeah, so I can figure out -4 would be a half to the -4, which would turn out to be 2 to the 4th, or 16. So I could plot -4 and 16. Okay? And then I can draw in my asymptote. Y equals 0. And then join with a smooth curve. Arrows on both ends. So there's the parent. Okay, so now I look at my image and decide whether it's ready to highlight or not ready to highlight.
It's not ready.
Not ready. Okay, good. So since it's not ready, I have to rewrite it with the 1/3 factored out of the exponent. So I have to rewrite a third x minus 2 as a third times something. Remember what that would be inside the brackets? A third x divided by a third is x, but what's -2 divided by a third? -2, we're good at dividing by fractions now. Divided by a third is the same as -2 times 3 over 1, which is -6. Okay? And then remember, you can always test yourself if you distribute a third times x is a third x. 1/3 times -6 is -2. So you know you've got the factoring right. Okay? And then we have -1. So now it's in the x part, or the exponent part is in factored form. So now we're ready to do our highlighting. So yellow, there's nothing out front. The only thing yellow is -1 at the end. And then green, there's the 1/3 and the -6. So there should be 3 transformations. And from left to right, the first one we get to is the 1/3, which is a horizontal stretch. Good. Horizontal stretch by a factor of what? 3. Good. And then the -6, horizontal shift, right 6, good. And then a vertical shift, down 1. Which means our asymptote's going to move down 1. And then we're going to move our, as we can, so we can start with 0 and 1. So I want to stretch it horizontally by a factor of 3. That doesn't change anything for me here. Horizontal shift to the right 6, so 1, 2, 3, 4, 5, 6, and down 1. So right here. Yeah. The next one I want to move is this one. So horizontal stretch by a factor of 3. So I'm 1 away from the y-axis. I'm going to be 3 away on this side. Then a horizontal shift to the right 6. 1, 2, 3, 4, 5, 6. And down 1. So I'd be right here. Okay. The next one I'm going to move is that one. So I'm going to triple my distance away from the axis. So I'm going to be 6 away, which is 1 off the graph. But then I'm coming back 6. 1, 2, 3, 4, 5, 6. There, sorry, and then down 1. We can try doing this one, but I think it's going to be off the graph, but if we can put where it would be up, it's going to be really close off the graph. So if I triple my distance away, I'm going to be 9 this way, but I'm going to come back 6, which puts me 1 off the graph here, and then down 1. And do it right there, which is a good guidepost when I'm joining my, that doesn't look right. 3 times 3 is 9. That 6 should put me at negative 3. Okay, sorry guys. So if you triple that, you're going to be at negative 9, but if you come back 6, you're going to be at negative 3. No, what am I doing? That is right, isn't it? So you triple this, so you're at negative 9. You come back 6, you're at negative 3 still, but down 1, so you'd be right there. So those are the easier ones to do. Then we'll do our half, which isn't too bad. So horizontal stretch by a factor of 3. So instead of being 1 to the right, I'm going to be 3 to the right and halfway. And over 6 to the right. 1, 2, 3, 4, 5, 6. And down 1. So that in the halfway spot right here. And then I know my patterns, every 2 I get closer to the asymptote. So 2 over, closer to the asymptote. 2 over, closer to the asymptote. And then you can connect them. There's on the ends. Like that. There we go. Alright, and it should look like it's stretched out horizontally, which it definitely does. Shifted to the right 6 and down 1. And then we need domain and range. So the domain is going to be all real numbers. And the range is going to be all real numbers as long as we are greater than, strictly greater than negative 1. Okay, so that is exponential growth or exponential function.